Before we dive into the latest news from Los Angeles, don't forget to subscribe to our channel and hit that like button if you found this content informative, engaging, or easel, which is testing in Mark. And as we navigate the complexities of wildfires in the Los Angeles region, a pressing question arises. What's the next big threat to the area? While firefighters battle the blazes, local authorities and emergency responders are equally concerned about potential future threats, specifically floods and debris flows in scorched hillside regions. A gentle drizzle on January 25th, 2025 may have been beneficial for firefighters, but it also raised the risk of hazardous floods and debris flows in charred zones. The National Weather Service issued a flood alert for these areas until January 27th, cautioning residents and emergency responders about the dangers of debris flows and debris flows, often referred to as mudslides, can travel at speeds comparable to freight trains, leaving destruction in their wake. They have the capacity to transport vast amounts of sediment during a single storm event, as evidenced by the incident in Montecito, California in 2018, which claimed 23 lives and severely impacted 400 residences. So what triggers those debris flows, and why do they occur frequently and pose such risks following a wildfire? As a geologist specializing in pyrogeomorphology, I can share some insights. Essentially, fires remove vegetation cover, leaving the soil unprotected and prone to erosion. After a fire, heavy rainfall causes water to rush downhill, picking up loose soil, rocks, and charred debris along its path, resulting in these destructive flows. When intense fires sweep across hillsides, the scorching heat reduces trees, shrubs, grass, and buildings to ashes, transforming the landscape into a desolate gray moonscape. This fiery heat not only obliterates vegetation, but also harms the soil, forming a resistant water-repelling layer known as hydrophobic soil. Initially, the slope was lush with vegetation, leaves, and trees that caught rainfall and spongy earth that absorbed water. However, it has now been turned into a desolate area, so coated with ash and scorched soil. This altered terrain no longer allows water to penetrate a millimeter. When it rains on charred terrain, such as this, water combines with ash, stones, and soil particles to create a thick mixture, or slurry, probably. This slurry of debris flows downhill along tiny channels known as rills, which gradually merge to become larger and larger rills. As a result, a swift current of sediment, water, and debris surges downhill out due to the exceptionally high sediment levels, particularly when there's an abundance of ash and clay. Debris flows display properties more akin to a thick slurry, similar to wet cement rather than typical streams. This fluid is capable of swiftly transporting massive rocks, vehicles, trees, and other debris downhill with great speed. In early January 2018, just a few weeks following the Thomas Fire's destruction of the hills near Montecito, a heavy rainstorm caused mudslides that claimed the lives of 23 and enforced individuals and severely impacted at least 400 residences. the physical features of a region, the level of fire damage, the strength of storms, and the properties of the soil all significantly influence when, where, and if take place. Maybe specialists studying fire and landslide events at the U.S. Geological Survey employ various factors to construct models that estimate the probability and potential dangers from post-fire landslides. Some of the triggers of debris flows are literally part of the landscape. In simpler terms, the angle of a watershed slope and the absence or minimal amount of clay in its soil are crucial factors that we might provide watersheds with gradual slopes, usually less than 23 degrees, and fewer clay and particle sizes similar to sand tend not to generate debris flows. As a devoted enthusiast, I've learned some intriguing facts about pyrogeomorphology, a fascinating field that connects fire, geology, and weather patterns. Two crucial aspects that significantly influence these events are the extent of the watershed that has been severely scorched and the ferocity and length of the storm we encounter. Approximately 21.8 million US residents reside within a 3-mile radius of areas affected by fires over the past 2 decades, and this population has more than doubled between 2019, 2005, with the 2005 water. And a recent study out of Central and Northern California suggests that almost all the growth in wildfire-affected land in recent years can be attributed to human-induced climate change. As a concerned citizen, I've noticed that our changing climate seems to be upping the ante on extreme weather events. It appears that for every degree Celsius the temperature rises, the atmosphere can hold about 7% more moisture, making these downpours more intense, particularly those spawned by ocean storms. In approximately 90% of the watersheds in the western United States, simulations involving fire, climate, and soil erosion indicate that post-fire sediment flow downhill is likely to increase mostly partial, and residents in areas where fires have occurred, even without subsequent rainfall, the debris on slopes may remain unstable. For instance, just after a fire swept through Pacific Palisades, a small landslide took place that split a house in half. A common occurrence in chaparral environments of Southern California following wildfires is a process known as dry rubble, which represents a significant form of erosion on hillsides. Study on charcoal fragments from ancient landslides indicates that fires and erosion have significantly influenced Earth's terrain for numerous millennia, yet the growing threat of wildfires in densely populated regions and the possibility of heavier rainstorms leading to more powerful downpours increases the likelihood of destructive and potentially lethal landslides. As their populations expand, community planners need to be aware of those risks and prepare. With that said, thanks for watching, and until next time.